It looks rustic, you know, like. It's
Oh, rustic. Is that a nice way of saying like a shithole? Hello, so today we're looking at the compound diazodinitrophenol, which is one of these so-called green primary explosives. Because while it's still horribly toxic and probably carcinogenic, it doesn't contain any heavy metal atoms, so it doesn't release metals like lead and stuff. There are two forms of it, the para-DDNP and the ortho-DDNP. And interestingly enough, I synthesized both of them from medicine, although one of them was from aspirin and one of them was from paracetamol. All of the videos of the synthesis of both these explosives are over on my second channel, if you want to check that out. Although there isn't a aspirin to picric acid video. If you want that, you should go over to Doug's Lab channel and subscribe to him and watch all his videos and like them all, because they're all a lot better than my videos. And you'll probably subscribe to them anyway, but you should go and resubscribe. Anyway, it took me about 3 weeks, so here's 3 weeks of work, you know, smashed into 1 minute of montage. But I'll let you use your imagination. Alright, 3, 2, 1. Alright, so what's the DDNPs actually like? Well, they're fairly sensitive to shock. It probably takes about 50% effort with a hammer to explode them, which puts them somewhere between nitroglycerin and the metal hydrazine nitrate complexes in terms of sensitivity. DDNP also burns really fast, but I wanted to see if there was more of a difference between the two isomers or within a different crystalline grade to the isomers themselves in terms of burn rate. And as you can see from the slow-mo footage, none of them really burn that much faster than the other. And that's what I found for every property in terms of like shock sensitivity and full detonation, is that the two isomers were very similar. The para isomer is meant to be slightly more theoretically better in terms of energy output and detonation or something, but really in reality there's basically no difference. I added different ratios of potassium chlorate to the DDNP because the DDNP is such an oxygen negative material that it would benefit from having some oxidizer added. But you can't really see too much effect from it. The most interesting thing is the smoke colour goes from a black to a white. I couldn't actually get rid of the black stain on the paper even when I added enough chlorate in there to definitely oxidize the carbon. DDNP does burn really fast, but it's annoying because that's basically all it wants to do. It never really detonates properly. And that comes down to it being a confinement issue. That was pretty crap. It's intensely crap, to be honest. It's a hell of a lot of confinement to actually detonate properly. Usually my method of wrapping the explosive in aluminium foil and then like compressing it before gluing the fuse down to it works really well for confinement. But in this case, it just appears that it doesn't work. It's just not enough for it. Because it burns so fast, some of these deflagrations actually are rather violent and still dent the can and stuff, but they're not proper explosions. I had one proper explosion, that's this one here, but apart from that, no. Also compared the para-DDNP to para-DDNP with different ratios of potassium chlorate in there under confinement, and I was actually quite surprised and a little disappointed by the results. And as you can see, the plain DDNP dented the can much more significantly than either of the DDNPs with the potassium chlorate. Obviously there are twice as many molecules of DDNP in that one than there was this one, because they were both 150 milligrams, but this one was, in that 150 milligrams was some potassium chlorate. But I thought that the gas, you know, additional gas generation and additional formation of more stable products like carbon dioxide as opposed to plain carbon would have made this dent more significant, but I guess that formation wasn't quite as favourable. So just the plain DDNP was still the strongest out of all of these. Finally, I tried sensitising the mix by adding a 10% per mass amount of silver azide to the mix. And I thought the silver azide would coat the crystals of the DDNP, and then when I heat it and everything, that would detonate, and then it would detonate the DDNP. And I thought that was a really great idea, up to the moment where I basically saw no results from that either. Although it possibly did a little bit better under confinement, but still, it was a load of shit. In conclusion, I found the synthesis of both DDNPs quite fun. It's quite interesting both theoretically and practically how to do it. I didn't have too many issues with it, which is surprising because I usually cock up everything I try. But the finished product is pretty crappy. I mean, it's trying, it's doing its best, but it's just shit. And I don't have the abilities to confine it really well. It's not really, I don't find it great, and I am going to stick with toxic metal explosives from now on, because at least they're not pieces of shit. If you like this video, you can support me on Patreon, you can write on my wall if you want to, or just, help me out. Subscribe, hopefully you already subscribed, don't send me hate mail. Actually do, I kind of enjoy hate mail. Anyway, goodbye.